Well, hello, good afternoon, everyone, and welcome. Welcome to another virtual demo brought to you by Rhino Toolhouse. This is, I believe, our 8th week of these live demos, and we're so glad that you were able to join us today. We hope you will find, or if you've been joining us, you have found that these have been educational, informative, and fun during these obviously very interesting times. Let me introduce myself. My name is Fred Wells. I'm part of the material handling team, serving as the Great Plains Material Handling Specialist. And I'm a part of a group of handling specialists that span the entire Rhino Toolhouse footprint. We're available, obviously, to assist all of our sales engineers, but also you, our valued customers, in reviewing and solving your most difficult material handling challenges. For those of you new to these Toolhouse demonstrations or Rhino Toolhouse in general, who is Rhino Toolhouse? Well, I think our mission statement says it all, and that is to identify and deliver the world's most innovative industrial solutions. I mentioned innovative, and innovation is one of our core values, which brings us to today's topic, which is fall arrest. And innovative in the sense that we're going to discuss a rigid fall arrest system, not a wire rope system that you typically see in industry. John Adams, our guest expert, will obviously elaborate on that here shortly. But before we get going, let me ask you a few questions just to get your mind engaged in our discussion today. Do you receive goods on flatbeds or even by train or rail car? And do you have workers or the folks assisting the loading or the unloading of such goods up on top of this equipment? Do you manufacture big or tall products where workers have to be up and on top of the product during its fabrication, assembly, or manufacturing? Are you yourself in charge of ensuring that your company meets the OSHA guidelines for fall arrest within your facility? And is retaining your current workforce and keeping them safe and healthy important for you? If you answered yes to any of those questions, then today's discussion is an important one for you and your company. So a couple of things before we begin. I just want to mention a couple administrative things here. You can ask questions during the presentation by clicking on the chat button, which should be on the bottom part of your screen. And really, for best viewing of this presentation today, selecting a side-by-side or selecting the side-by-side mode under view options will help you do that better. So are you ready to take a quick ride over to Gorbel in Fishers, New York? Gorbel, for most of you that are aware of, is a world-leading manufacturer of workstation cranes, jibs, and hoists, along with the world-famous G-Force. G-Force is a servo-based technology and offers many benefits over typical hoists. By the way, Gorbel is introducing new versions of the Q and IQ, the new Q2 and new IQ2 versions as we speak, so look for more information on that. So with that, I'll pass the con over to John Adams, Technical Sales Engineer for Gorbel's Tether Track division. He's standing by and ready to go. Hello, John, how are you?
Hey, Fred, how's it going?
Great, great.
I would like to thank everyone for coming out to spend some time with us today, and thank Rhino Toolhouse for having me. I'm hoping to have a conversation here today with you guys. We're going to talk a little bit about fall protection in general, and what that means. We're going to talk about what fall protection actually is. We'll discuss some of the things that will actually make us fall, how we might minimize falls, some of the statistics around it. We'll also talk about the ABCs of a full fall protection system before looking at some more specific applications. So I guess getting right into it, what is fall protection, right? Looking at this photo here, this looks like it's some pretty good fall protection until you realize they aren't tied off to anything. So fall protection is any effective means of preventing injury while working at height. And that's great, working at height. What does that mean? Well, depending on your industry, that changes a little bit. According to OSHA 1910, that's the general industry standard, working at height is 4 feet. If you look at OSHA 1926, the construction standard, working at height is 6 feet. So it's a little different depending on your industry. What are things that make us fall? It can be any individual or combination of the things you see in front of you. Very common, it can be little or no training. Environmental conditions, is it wet, is it slippery? I can't tell you how often the incorrect equipment selection and misunderstanding your total fall distance and fall clearance is something you see. I've been in multiple facilities where a worker says, okay, 4 feet, got to be tied off, got it. Let me go get my 6-foot lanyard. Not doing you a lot of good. The it won't happen to me mentality is another big one. Thinking I'll catch myself. In actuality, when a human falls, the instinct is to actually tense up, not to reach out and grab things. So, those are just a few things that could make us fall. And we do, right? Every year, there's over 100,000 injuries and deaths attributed to work-related falls. And per the NSC, the National Safety Council, falls are always one of the leading causes of death in the workplace. It's always very close to the top of the list. And there's many things that you lose in a fall. There's the very obvious things, right? There's permanent injuries that can occur. There's loss of life. That's why we get into this, to stop those items. But there are also things that happen aside from that can affect a company. Millions of dollars of losses due to significant increases of insurance premiums is a big one. Workers' comp claims, the product liability, there's other related expenses. If you have multiple workers that have fallen at your company, it's going to be hard to find good, talented people to come work for you if they don't feel like they're safe. So I have some numbers here from 2013. There were roughly 4,100 worker fatalities in the private industry, and about 20% of those were in construction. In that construction field, 58% of those were caused by what we call the fatal four. And the fatal four is falls, being struck by an object. So, someone 2 floors above you drops a hammer. Electrocutions, or being caught in between, or caught in machinery. And what's interesting to look at these is that if you look at falls, that has more occurrences than the other 3 combined. So if you were to eliminate the fatal 4, you'd be saving roughly 500 worker lives in America each year. On average, there are 2 employee deaths a day in America. So fall protection, what is it, right? What is a complete system? You really have your ABCs, your anchorage, your body support, and your connector. So an anchorage is defined by, it's a secure means to which a personal fall arrest system can be attached. So looking at this example, it is not an anchorage or a harness or a lanyard for that matter. This would be pretty ineffective. I think we can all agree with that. You may notice our friend here is not wearing gloves, so it's very unlikely he's going to be able to grab hold of this rope. And if he is, it's very likely, if he had vice for hands, he's probably going out the window with the person he's holding the rope for. So this would not be a good fall arrest system. So with your anchor, you have an Anchorage Connector, right? And that's a piece of equipment that it's actually used for a means of attachment for the lanyard or the SRL to the worker from the anchor point. So in this example, you got the W beam there is our actual anchor, and the beam clamp is the Anchorage Connector. And these can look a variety of different ways, right? So depending on what your application is, you could have rooftop anchors, concrete anchors, tie-off adapters, our rigid rail systems, the trolley there is an Anchorage Connector. And there's different requirements depending on what that anchor is being used for. You'll commonly hear people refer to certified and non-certified systems or improvised systems. And there's a different requirement depending on which is which. So when you're using a non-certified improvised system, it's just that, right? It's a system that's not specifically designed for fall protection. Whereas a certified system is designed by a qualified engineer to the OSHA regulations. So if you were using a restraint system, an improvised system would need to be able to withstand a static load of 1,000 pounds, whereas a certified system would be twice the foreseeable force. Again, it's a little bit different in work positioning, where you'd have to have a static load of 3,000 pounds if it was a non-certified system. And it would also have to be rigged so that the worker can't fall more than 2 feet. And again, the certified would be twice the foreseeable force. Rescue, again, is a little different. The non-certified improvised system would need static loads of 3,000 pounds. And the certified system would be a 5 times the foreseeable force, a 5 to 1. And that's because you're lifting and lowering people typically with a rescue system. Now, when it comes to fall arrest, A non-certified anchorage must be capable of supporting a load of 5,000 pounds per worker. I'm sure many of you have heard this before. All the times I hear people mention the 5,000 pound rule. And at Gorbel, our tether track systems don't need to meet that because we have qualified engineers on staff that design all of our systems to 2 times the maximum arresting force. So the maximum arresting force is the force felt by a worker at the bottom of a fall. So because we have the qualified engineers on staff, we can design to a 2 times MAF. Once you have your anchorage, you need some kind of body support, right? And that's going to provide a connector that's actually on the worker back up to the anchor you have. And these harnesses, they're designed, you can see that these straps cross in the back there, and you have the D-ring going through them. And it does that so that it can, in the event of a fall, the forces are evenly distributed across the strongest points of the worker's body, over the shoulders and the legs there. I'll talk about the body belt in a second here, but it also has built-in fall indicators. So you can see this stitching on the back here as an example. In the event of a fall, that actually rips out. And so you can know if a harness has been impacted just by looking at it. And you would also get a little bit of force absorption from that. Now, the big advantage of body harnesses over body belts is that harnesses are legal. You're not allowed to use body belts for fall arrest anymore. And you can see why looking at these photos. If you were to fall in a body belt, you get a single point load of where that fall is arrested. And so for the person in our photo here, that's right around his waist. You know, could really damage his organs. If the D-ring was in the front, you have the possibility you could break a back, having the anchor point in front of him. So the harness, while neither is comfortable, the harness is going to distribute those forces much more evenly and be much safer for the worker. Where you will see a body belt is mostly in fall restraint. You can see it in work positioning as well, but it's not as common anymore because most of the time the work positioning harnesses include a body belt on it as well as a spot for fall arrest, because you would still need to be tied off. In work positioning, that belt acts as one of your 3 points of contact. So what ties it all together? It's our connectors, right? So that's going to be any snap hooks, carabiners, lanyards, SRLs, anything like that, right? It connects the anchor to the worker. And all of these need to have a minimum tensile breaking strength of 5,000 pounds. The reason being is, you don't know ahead of time if this is going to be used on a certified or an improvised system, so it needs to be ready for anything. Snap hooks and carabiners both have to be double acting, so you need to do more than one movement to open it. And that's so you don't get a forced rollout, or if you twist it in a certain way, the gate doesn't open for you. They also need to be auto locking, so when you let go, it needs to be able to snap shut and be in place. As I mentioned, in the vertical orientation, it needs to be rated for 5,000 pounds. And in the US, ANSI has the gates rated for 3,600 pounds. The other big thing is you have to have a compatible connection. So what do I mean by compatible connection? It would be one open to one closed. So your D-ring would be closed off, and your carabiner or your snap hook would be the open section. So looking at some improper connections here, 2 hooks in one D-ring, right? You want one open, one closed. So the 2 hooks in the one D-ring would be improper. In B, you're seeing that the gate is being loaded, and that's not ideal, right? These are designed to be in the vertical orientation where they're at their strongest. C is fairly common, actually. It's a false connection, and this happens when a worker is attaching to their back D-ring. They may think they've hooked themselves up, but in actuality, their hook has actually just gotten stuck there. So if they give it a tug, it might not come out. They think they're connected, but then if they were to have a fall, they'd be in for a surprise. It's really important to have people working at height, not be working alone, have someone else in the area, a buddy that can check out, make sure that there is a proper connection. When you look at these 2 in D, again, that's 2 open connections. You need to have your open to close. E is interesting. It's tied back to itself. This is improper because it's not designed for that, right? You can buy products that are designed to tie back to themselves. So I encourage you to read the label, know what you have. But if you're if your item isn't designed for that, what can happen here is the webbing or the wire rope can rub up against the snap hook and actually cause wear, which could cause it to fail or cause a fray in the line. And then with our F here, that's just, it's not a closed connection, right? You need that gate to close. You don't want it to be able to slide off. When you look at rigid rail fall protection, you're going to see it being used with SRLs, self-retracting lanyards or lifelines, almost exclusively. And that's because these are meant to be anchored directly over the head of the worker. And that's going to reduce any free fall. In some cases, it can really eliminate it. And it also reduces swing fall. You won't get a pendulum effect. And the way those work, it's very much like the seatbelt in your car. They extend and retract with the worker. And when you hit a certain speed, they lock right up, stopping the fall. These could be nylon, galvanized, stainless steel. There's all sorts of materials you could see. And there's specific SRLs for specific applications. So a leading edge unit would be used if the line would have a possibility of coming in contact with another surface. Whereas a sealed SRL unit would be used typically in an outdoor or in a grimy work environment, and it prevents moisture or gunk from getting inside the housing and kind of gumming up the works. So I'd like to talk to you a little bit about the advantages of a tether track rigid rail system versus wire rope and I-beam specifically. We'll start with wire rope though, because I think that's one of the more common solutions you see out there. One of the big things right off the bat is there's less fall clearance that you need. With a wire rope system, when you fall, you can see there's this dynamic sag. And so that actually increases the amount of clearance that the worker needs before the fall is arrested. Whereas our system, being the rigid rail, you don't have that sag. You can catch the fall almost immediately, allowing the worker to self-rescue in most cases. It's also safer for multiple people. And the reason for that being, when this worker falls and this dynamic sag happens, the line has to come from somewhere. And it comes from elsewhere in the system. So this worker, in that case, would have the line above him get pulled tighter, and that can actually cause him to fall as well. And that can go into the reduced risk of secondary fall injuries. With this dynamic sag, if you fall next to the support, or really anywhere, that worker is going to go to the middle of the span. So in this case with the rail car, there's a possibility if they fell over here, they could slide into that rail car. And if this worker, the second worker, were in the same span and the first person were to fall, they would both meet in the middle and they could collide into each other. We can also do longer support centers on our track because we don't have to worry about the tension on the line. And it also allows us to cantilever past the last support. So you get additional coverage past where your actual supports are. Another advantage here is when you look at the wire rope systems, if you're putting them in a ceiling, is buildings are structurally soundest in a vertical orientation, right? If you have a vertical load on that building, it's happy. They're not great in a horizontal orientation. So with a wire rope system, when you have a fall, you have the vertical impact of the worker falling, but you also have the horizontal impact on the building of the rope being pulled. With our systems, it's only a vertical loading, so it's actually a lighter load than you would see with a wire rope system. I had mentioned two workers in one support center falling and both sliding to the middle of the system. Here's an example of that. There appears to be about at least 5 people in there. That's pretty scary. And it's also a very difficult rescue to do. And in this photo, that was scaffolding had fallen out from underneath the workers. And you can see right there how much sag there is in this line. I would really like to be that guy. He lucked out on that one. So looking at I-beam, our enclosed track, it's cold rolled with a 2-degree taper that self-cleans, allows dust to kind of fall out of there. And we have various track profiles to meet whatever application we need to, right? We have a very low headroom plane track, it's called, which is just the bottom rail. And we have a truss track, which is a little bit deeper. It almost looks like a ladder for longer support centers. And we have a dual truss track, which actually has 2 pieces of bottom rail so that workers can bypass each other if need be. And this prevents us from oversizing the runways, right? We can really tailor it down to your application, and it's not a one-size-fits-all. It's also much lighter than an I-beam would be, so you don't have to worry about the loadings in your ceiling nearly as much. It's a much easier install as well. And on top of that, because our track is enclosed, you don't have to worry about dust or water or ice or anything like that building up on the flange and impacting the rolling of the trolley itself. And then so looking at a few applications here, what you're seeing here is one of our most popular systems. It's called a fold-away system. If you have large overhead cranes that are in your work center, or if you have infrequent need for fall protection, a fold-away can be a great solution for you. And these can actually move out over the area when you need them to get the workers up to height. But if you need to bring in the large overhead cranes, you can actually fold these back against the wall to get the fall protection out of the way. So it allows you to kind of have your cake and eat it too in that sense. And we recognize that you don't always have a fall hazard in the same place every time you need a worker at height. So for those times, we have things like our portable gantry system here. And this would be one worker or two worker, various heights and widths. And you can roll this into place, get the worker up to height. They can do what they need to do safely and then get back down. If you're using it infrequently, you can just undo the bolts here at the top of the boom, and it stores nice and out of the way, so you're not taking up a lot of real estate with it. Another common application we see and get requests for a lot is attaching to existing overhead bridge cranes. And you can do this. The important thing to remember, though, with it is having a plan in place to make sure that the worker is safe. So you want to have some kind of lockout, tag out going on with the bridge while the worker's at height. You wouldn't want someone on the floor not knowing someone's tied off to the system, moving the bridge and sending them for a ride. It wouldn't be good. So what you're seeing here is we attached our rail to a top running bridge crane using our flush mount hangers. We've also done a similar design for bottom running large cranes that it almost looks like a C-track. We'll do haunches that come off the top flange, and then the rail will be right next to the lifting bridge. We also do bridge systems as well meant for fall protection. So you're seeing the aluminum bridge here. We do that so that the bridge is lighter weight, so it follows the worker as they move about the work area. And these are great because rather than giving you a straight line of coverage with a 30-degree offset, it gives you coverage in an entire rectangular area. It gives you a lot of versatility for where you would have the coverage. Gorbel has been doing this for a very long time. The company just had its 43rd birthday, and so we've gotten pretty creative with putting our rail in the air. And so what you're looking at here is a single pole system that has one foundation here, and it's supporting two different rails, 2 workers per rail, and these are about 61 feet long. So you have one support point for 61 feet of coverage on either side. And what's great about the enclosed track is if you find that you need more coverage down the line, you can just add right onto it, splice, and continue the rail as long as you need to. So looking here, this is again our dual track, our ZD track. This goes through an entire maintenance facility at a rail yard, and you can see how long it goes. This goes indefinitely. If they needed to add another building on, they could, and we could add more splices and just keep the rail right going with a seamless transition. I know that was a lot of information and not a lot of time. I would like to thank all of you for taking time out of your day to spend it with both myself and with Rhino Toolhouse. And I am happy to answer any questions you might have.
Thank you very much, John. We do have one here. Are there any mobile solutions that Gorbel offers?
Yeah, so we have some tow-behind units that we do called the Ranger and the Road Ranger. The Road Ranger is capable of being towed on the highway up to 65 miles an hour, where the Base Ranger, it's more of a on-campus unit. And those are adjustable height from 18 to 22 feet and can be moved from site to site to give you coverage in a cone shape.
Perfect. In the event of a fall, do I need to replace my tether track system?
You don't. That's actually a big advantage for tether track systems, is they can be reused after a fall event. There's an inspection criteria you would need to do, but unlike other systems, wire ropes, those typically need to be completely trashed and replaced after a fall has happened on them. That's not the case with the tether track systems. You would just need to do the inspection and you're back into work.
Does the tether track allow multiple workers to pass each other without unhooking or getting tangled?
Yeah, our dual track, our bypass track, since it has two independent bottom rails, you can have a worker tied off to either one and they can pass each other without unhooking, without getting tangled, with ease. So it's much safer for multiple people in a tighter area.
Does tether track have any curved rail available?
We do. We have a couple ways to deal with curves. We have a standard curve that does a 90-degree turn. And that's for more, we use that a lot when following conveyor lines for servicing those and things like that. But we also can cut and splice our track at an angle of about 5 degrees for longer systems. So if you have a long, gentle curve across a rail yard, we can actually match that so that you don't have to put multiple systems in different areas.
All right, we'll give it just a few more seconds here in case anybody has any questions. Question from Dave Johnson. Are the Bills going to win the AFC East this year?
Undoubtedly. Then you heard it here first. The Buffalo Bills are going to take over the AFC East.
It's a big statement. All right. Aluminum versus steel painted tether track.
Yes, so typically you're only going to see us use aluminum in a bridge orientation. And that's because the aluminum is really great for following the workers. It's not as good at 30-degree offset. So in a monorail configuration, we really only use that if we know that the worker can really only fall straight down. We do have a system that's on a library that actually spans a river. And so there's no big platform for the offset. They're either on their ledge or they aren't. So typically you will see us use the steel in a monorail. And that can be, we have outdoor finish for that if you have outdoor. Typically it's a baked enamel, but we can do whatever you really need to as far as finishing goes on.
That's great. All right. Well, I think with that, we'll wrap it up. If you want to take it away, Fred. Thank you very much, John.
Yes, I just want to give everyone a quick reminder that just like the other types of workstation cranes and jibs that we provide from Gorbel, Rhino Tool House can also assist in the installation of these items. So we would work with John and his team to engineer and design a system for you. And once the components arrive, we can help you with the installation of them as well. So John, thanks again for your time. We appreciate it. We want to thank all of you participants for joining today. Thank you for your time. And as always, please contact your local Rhino Tool House sales engineer for more information, for a site visit review, or a quote on a fall arrest system. So that ends it pretty much for today. Just want to give you a primer for tomorrow's exciting topic. Do you need to ever pick and place or orient parts efficiently and safely? Have you allocated enough additional labor to lift and move parts that are maybe large, hard to move, or have to be oriented in a certain orientation for placement? Well, if you answered yes to any of those, tomorrow's topic is on manipulators, and we'll be going to advanced manipulators in Minnesota for a much deeper discussion. So thank you again for your time, and have a great day.